Okay, I'm going to open up a ronchigram. Let's see right here. This is of a 135 f5.5. Here it is. I'm going to test this against diffract to see if I could interpret any, the amount of error. Okay. Let's see. Here's my program, diffract. Also, along with diffract, I wrote an Excel sheet to help me calculate the error because I don't want to do it all the time. So let me open that, set that up. See, it's 130. It's 5.5. Here's the radius of curvature. Let's open up diffract so we can start to put in the diameter. It's 130. The radius of curvature is 1429.97. Okay, we're going for a perfect parabola at first, so keep the constant, the conic constant right there. Now this number opens up this window to be bigger, so I always keep it at 512, which is the largest. So now that we could get a bigger image, and this number right here zooms in and out. If your mirror is really large, you have to make this larger so you zoom out. So let's see, let's go to the mask. We're not going to have any mask, no pin stick. We're going to do Ronchi with the 4 lines per millimeter, red light, and a moving light source. Sometimes I forget to put that in, and it makes all the difference in the world. So let me see, do I have everything? So this is at the radius of curvature. We'll run it right now and see what it looks like. Okay, let's make this a little bigger. So we'll zoom in, make this number smaller so we can make this bigger to match what I have. Okay, now we go to the radius of curvature. Now my ronchigram is outside the radius of curvature, so we want to put a positive number here. So I'm going to start off with the 5 millimeters to see where we're at. Okay, you can see we're outside the radius of curvature because of the curve direction. But I have 5 lines on the ronchigram, and this has 2. So let's go a little further out. 10. I like to make my measurements increments. That's way too many, but also it's really dark. So my light source, I use a big LED, 3 millimeter, 5 millimeter. But this program I have to do like 0.3 millimeter, or else it gets really bleached out, or 0.5, you'll see, to try to match this. This is overexposed, that's why the lines are so thin. Let's see, so let's go back to getting it closer to the radius of curvature. I started out at 5, 10, so let's go in between 7.5. Let's see what it looks like. Oh, okay, that's cool. Now let's see, let's try to get this in line, this in the center like that. So I'm going to move over to the left in little small increments. If you make too large a jump, you'll think this moves over this, but you're actually jumping this line. So I only do small jumps so I can watch this line move over little by little. A little more. You can see that there's some light here. It's getting close to what we have, 7.5. But you can see that my mirror is undercorrected compared to this, where you can see a nice bow here. You see like kind of like a flat spherical, then a parabolic shape down here, and it's flat again. So if I average that out, it'd be not this. So let me see. Let me move it over, center it a little bit more. I mean, not center. Yeah, let me center it here. And then let me look at the light source, 0.3. Let me bleach it out a little bit more. 0.5. Trying to match this, but you can see it's curved a lot. So this is when I go to my Excel sheet and I put in the wavefront error that I want to test for. See this? See if it's 1/4 of an inch. Now this is the formula that diffract in the help menu tells you to use, and you take this number and you subtract it from the conic for overcorrected parabola, or you add it to the conic constant for an undercorrected parabola. So I'm going to take this number and put it in that B value, which would be minus 0.647, right? 642. 642. Okay, now let's go back and get the, where's the image? Okay, here. And let's watch it. See how they match. Did it run? Okay, straighter. I can see, but this looks still not as curved, and you can see maybe if I averaged it, it would look more curved like that. But this is the outsides you can see that are still more curved. So let me hopefully overshoot it and test for half a wave under correction. This is the B number. I can't see it. So I'll go minus 0.283. Why does this one keep on going? Keep this up. Run it. Okay, since it's straightened out, where it looks like we're a little bit further away from the radius of curvature, so we'll move it in a little bit more. A little more. So that looks pretty, that looks actually more straight than this, even though this isn't like a nice curved line. So at this point I would say, okay, it's not a half of a wave, even though this is really close. The outside, this center section, I don't think it's as flat as that. I would say it's in between that half of a wave and the 1/4 of a wave. Let's go to 3/8 of a wave and see. Where's the Excel? Take this again, put it in B. Why does it keep on disappearing? Minus 0.462. Let's match it and see it run. No, this is actually still flatter. even though if I average this curve over, it might match that. But I can see I need to correct this. Alright, at this point I would take it to a foco or set up an auto collimation, which I haven't set up yet. But I would use this program to rough guesstimate what this figure is before I go further. So that's that for diffract.